All right, we are wrapping up chapter 3 here in this one video. Okay, so take notes. This is 3.3, definition number 3, circular functions. Okay, so make sure you are keeping up with the homework on WebAssign and make sure you are checking in for attendance every week. Okay, 3.3 definition. Definition 3, circular functions. Okay, so we're going to take a look at the unit circle, and we're going to connect that to the definition of the different trig functions. Okay, so definition number 3. If xy is any point on the unit circle, so for those of you guys who don't know what a unit circle is, it is a circle with radius 1 equal to 1. Okay, so that's what a unit circle is. Okay, so if xy is any point on the unit circle and theta is the angle formed, then sine theta equals y, cosine theta equals x, and tangent theta, since tangent theta is sine over cosine, equals y over x. Okay, and of course x is not 0, because then that would be undefined. Okay, let me do a drawing here. So suppose that you have this this unit circle. Centered at the origin. Okay, and so if you have some point xy on the circle, so maybe it's there, who knows, but it's somewhere on the circle. Okay, so then you have this here, and again, it has a radius 1. Okay, it has a radius 1 that looks like just a marking. Let me do it this way. R equals 1. Okay, so we have that radius 1, and here is our theta. Okay, and so here, sine theta equals y, cosine theta equals x, and those two come from that point right over there. Okay, and here, let me just do, okay. And here they're using theta interchangeably with t. Okay, so if you see, sine theta, or you might see sine t, okay, they're talking about the angle. All right, so let's take a look at this here. We already explored this, so we'll just do one example here. Find the 6 trig functions. The 6 trig functions: sine, cosine, tangent, cosecant, secant, cotangent. So the 6 trig functions of 5 pi over 6. Okay. All right. So this fraction does not reduce. So the reference angle is going to be pi over 6, which is associated with 30 degrees, right? Okay, so let's go ahead and draw and see which quadrant it lands in. Okay, we want 5, 6. So that's 1, 2, 3, 4, and 5. Okay, so we land here in quadrant 2, right? So we land here in quadrant 2. So keep that in mind when we find the 6 trig functions. Sine, cosine, tangent. Okay, so it has reference angle pi over 6, which is 30 degrees. So this is going to be 1/2. It's in quadrant 2, so it will be positive 1/2. Over here, this will be square root 3 over 2. It is in quadrant 2, so it will be negative. And then tangent, since tangent is sine over cosine, it is going to be negative, and it will be 1 over square root 3, or so here's one way to look at it. If we rationalize the denominator, then we get negative square root 3 over 3. Okay, and then the other 3 are the reciprocals. So cosecant of 5 pi over 6 will be 2. Secant of 5 pi over 6 will be negative 2 over square root 3. But if we rationalize the denominator, we get this. And then cotangent of 5 pi over 6 will be the reciprocal, but I'm going to use this fraction instead, so I'll do negative square root 3. Okay. All right. So, but we focused a lot on this in the last section. Okay, so you might get a question that says this in the homework. Find all values of t, which is your angle. So all values of t between 0 and 2 pi. So that's like saying 0 and 360. So between 0 and 2 pi, for which sine t equals 1/2. Okay. Well, so we already know sine of 30 degrees is 1/2, right? So 30 degrees is associated with pi over 6. Okay. All right. So let's take a look. So I'm going to cut that into 6. And same thing with here. Okay. So we want to know where sine is equal to positive 1/2. So that's only the upper half of the circle, right? Because sine is positive in quadrants 1 and 2. So we don't even need this part here. Okay? And so that's going to be here and here. So how many sixths is that? So this one is pi over 6. And this one is 5 pi over 6. Okay? So that would be your answer. Okay? All right. Let's take a look at something not so obvious. All right, so let's take a look at this one. Find tangent t if t corresponds to the point negative 0.737, oops, comma, 0.675, okay, on the unit circle. On the unit circle. Okay, so when we looked up here, we said, okay, well, sine theta equals y, cosine equals x, and tangent equals y over x. Okay, so we're going to use that over here. All right, so we already know. Let me change colors here. All right, so we already know this is x, this is y, and we also know that tangent t equals y over x. Okay, so that's what we're going to use. Okay, so we're going to use all of these pieces of information here. We know that, we know our x and y, so we should be able to find tangent t, which is what they're asking us to find. Find tangent t. Well, tangent t is y over x. We have y and we have x. All right, so tangent t equals 0.675 over negative 0.737. And if you punch this into your calculator, you will get negative 0.916. Okay? All right. And then you're going to get a question like this next one as well. And it has some interesting vocabulary here, so we need to go over it. So you might see a question that says this: evaluate sine 9 pi over 4. Okay, fine, no problem. We did that in the last section. Okay, but then it'll also say this: identify the function. These three things. There's three things here. Identify the function, the argument, and the value of the function. The value of the function, that one's easy. That's just the answer, right? The value of the function. Okay, so I need to go over what the other two things are. Okay. So the function, well, so we have 6 trig functions, right? So they want to know which of those 3 trig functions are we using here? Well, all right, pretty straightforward. Sine. Okay. So the function is the sine function. Okay. The argument, so if you're a computer science major, then you kind of work with functions and arguments. And so that's kind of the same thing here. So the argument is the, the, the thing that you're passing through the function. In this case, that would be 9 pi over 4. So we're passing 9 pi over 4 through the function sine, and we get this output, which is the value. Okay, and the value is going to be the answer. Okay, so let's go ahead and find the value. 9 pi over 4 does not reduce, so it's going to have a reference angle of pi over 4, which is associated with 45 degrees. So we know that it's going to be square root 2 over 2, but we need to figure out negative or positive. So let's figure out, where does 9 pi over 4 fall? Okay, so I'm just going to count 1/4, 2/4, 3/4, 4/4, 5, 6, 7, 8, 9. So 9 pi over 4 lands here in quadrant 1. So it'll be positive square root 2 over 2. Okay, so that's all this means here. Identify the function, the argument, and the value. The value is the answer. The function is the trig function that they're using. And the argument is the thing that you're passing through that function. Okay. All right. And then this last part, radians and calculators. So we know there's a lot more angles other than 30, 45, and 60 in the quadrantals, right? So there are other radians um, other than pi over 6, pi over 4, pi over 3, right? So just like when we were dealing with degrees, when we're outside of those quadrantal angles and those three basic ones, we are going to use our calculator. So the important thing is to make sure that your degree radians, and there's a third unit of measure there, gradients, and you need to make sure that your mode is set to radians. So just be careful with that. And then just check and see if you get this. Punch this into your calculator. We know sine of 30 degrees or sine of pi over 6. Sine of pi over 6 should be 1/2. So just punch that into your calculator and make sure that you are indeed getting 1/2. Okay? All right, so let's take a look. If you have to evaluate the secant of 3.47 and round to 4 decimal places. Okay, so we don't have a secant button, but we do have a cosine button. Okay, so we do know that secant 3.47 is the same as 1 over cosine of 3.47, right? So we can punch that into our calculator. And if you do, you should get negative 1.0565. You definitely should check that. Okay, make sure that you are in the correct mode and make sure that you are getting the correct answer. Okay. All right. So that's radians and calculators. And then there's one part here in 3.3 dealing with domain and range. So this is really more for you future math majors, domain / range. So this is a little more theoretical here. This is going to play an important role when we cover the topic of inverses more in depth later on. Okay, but the domains. Okay, so domains. All right, so for sine and cosine, the domain is going to be all real numbers. Okay. If you want to write that in interval notation, you could write it like this: negative infinity to positive infinity, right? Okay. For tangent and secant. So here, tangent and secant. Those can be written as ratios with cosine in the denominator, right? So here we don't want to end up with undefined. So we don't want to end up with cosine being 0, right? Because tangent is sine over cosine. Secant is 1 over cosine, right? And we don't want cosine to be 0. And that happens at pi over 2 and pi over 2 and at 3 pi over 2, right? At 90 degrees and 270 degrees. Okay, so we can say that the domain, in other words, we can use any angle So all real numbers except we can't have the ones we can't have t be pi over 2, right? And we can't have pi over 2 and 3 pi over 2, right? Pi over 2 to 3 pi over 2 is 180 degrees, right? Or pi, right? So we can't have pi over 2 plus k pi. This covers, here, let me show you. This is pi over 2. If you add 180 degrees, you'll be here. Okay, this k means we're adding pi many times. So if you add 1 pi, you're here. If you add 2 pi, you're over here. If you add 3 pi, you're here. 4 pi, you're here. Okay, so, and remember, we have infinitely many coterminal angles, so we need to make sure we cover all of them. So we can use all real numbers except t equals pi over 2, starting with pi over 2, and then plus k pi. And this is for any integer k. All right. And then cotangent t and cosecant t. These are the ones that have sine in the denominator, right? Cotangent is cosine over sine, and cosecant is 1 over sine. So we don't want sine to be 0 because then we get undefined, right? So it's going to be all real numbers except t equals, when is sine 0? At 0 and at 0, right? So at 0 and at 180. So 0 plus pi, but we want it any number of times. Okay, so 0 plus k pi, now 0 plus k pi is just k pi, right? So t equals k pi, any multiple of k pi for any integer k. All right. Okay, the range. So for sine and cosine, the range goes from -1 to 1. So you'll never get sine of something is 2. Okay, that's not going to be possible. Tangent and cotangent, you're going to get all real numbers. So it is possible to get tangent of something is 2. Tangent of something is 20. Okay, so you can get any real number. If you write that in interval notation, that would look like this. Okay, and then secant t and cosecant t, your range is going to be -infinity to -1 inclusive, together with 1 to positive infinity. Okay. All right, so you'll get a question like this on the homework. It's more of a multiple choice kind of a thing. So you'll get something like this: determine which are possible. And so you'll have these choices like, okay, is it possible to get sine of z equals 1.5? And or cosecant of z equals -345. And then here, tangent of 3 pi over 2 equals z. Okay, so and so this is going to be based on all of these things up here that we just wrote down. Okay, all right, so here is Is it possible to get 1.5? No. Okay. Because remember, sine of something, the highest it'll go is 1. The lowest it'll go is -1. So it's not possible to get 1.5. All right, cosecant z, -345. Is it possible to get that? You can look here. Is -345 in the range? Yeah. Okay. So this is possible. Okay, what about this one? Tangent of 3 pi over 2. Well, first of all, what is 3 pi over 2? Tangent 3 pi over 2. 3 pi over 2 is over here, right? Sine of that is -1. Cosine of that is 0. So is it possible to get this number z? No, this is not possible. We get undefined. Okay. All right. And so you'll get like 1 or 2 of these multiple choice kind of questions in your homework. So just use your charts here. Okay. All right. So that is it for chapter 3. Keep up with the homework, and I will see you next time.